Right now, the ground feels stable. You look up, the sky is clear. Space appears silent and motionless. But somewhere out in the dark, an immense wave of energy could be rushing toward us. It produces no sound. It triggers no warning sirens. It travels at the exact speed of light. If that invisible wall of radiation struck the planet, the atmosphere would begin to break apart in a fraction of a second. The protective shield that allows biological life to function would collapse, and molecular bonds across the surface would shatter before a single nervous system registers the event. The everyday safety we feel is an illusion. It exists entirely because of the extremely narrow, localized scale through which we experience reality. To grasp the actual mechanics of our vast universe, we have to look past the edge of our solar system, out into the vast emptiness between stars. Out here, distances render our fastest machines irrelevant. The sun is a massive nuclear reactor. Every single second, it outputs vastly more raw energy than all of human civilization has generated in its entire recorded history. Yet, watch what happens when we place the sun within the broader Milky Way. Our almighty star shrinks down, disappearing into a swirling cloud of 100 billion others. Within that sprawling galactic structure, massive stars live out their lifespans, and under highly specific, rare conditions, their eventual deaths trigger catastrophic physics. We cannot comprehend the lethal threats of deep space while anchored to a human perspective. We have to view reality through a galactic lens. For millions of years, a massive star, one much larger than our sun, sustains itself through a delicate physical standoff. The crushing inward pull of its own gravity is perfectly balanced by the outward push of nuclear fusion burning in its core. Eventually, the fuel runs out. The balance fails. The core implodes inward on itself in a fraction of a second, pushing the laws of physics to their absolute breaking point. In certain rare cases, the collapsing star does not explode outward in a uniform sphere. Instead, it channels its dying mass into two hyper-focused jets of pure radiation, firing in exact opposite directions. Astronomers call this a gamma-ray burst. It represents the most violent release of energy known to exist in the observable universe. This bar chart compares the total energy our sun will emit over its entire 10 billion-year lifespan to the output of a gamma-ray burst. The collapsing star compresses a 10 billion-year energy budget into a fraction of a second. By focusing that energy into a tight beam, the dying star acts as a cosmic sniper. It leaves the vast majority of surrounding space completely untouched, but incinerates anything caught directly in its narrow path. Step back even further. Beyond the Milky Way lies the Local Group, a cluster of neighboring galaxies bound together by mutual gravity. Beyond that sits the Virgo supercluster. On the largest scale, the universe is a web of galaxy filaments. Gamma-ray bursts erupt randomly throughout it. An inset graph of our telemetry shows astronomers constantly detecting these explosions as tiny spikes. Because we log these signals so frequently, the math points to an uncomfortable reality. Extreme, localized destruction is happening out there every single second. The wider universe is characterized by constant, ferocious violence. The quiet stability we experience on Earth is a profound anomaly. Bring the focus back down from the cosmic web. Zoom back into the stars forming our own Milky Way. Astronomers are currently monitoring massive, unstable stars within our own galaxy. They possess the necessary mass and rotation to eventually produce a gamma-ray burst. If one of those stars collapsed and its pole was pointed directly at Earth, the atmospheric impact would be instantaneous. The ozone layer disintegrates entirely, immediately flooding the planetary surface with lethal ultraviolet radiation from the sun. Planetary mass and orbital distance offer no defense against a focused beam of radiation. Surviving a cosmic sniper shot comes down entirely to the geometry of alignment. You are either in the path of the beam or you are not. Following the sudden loss of the ozone layer, the base of the food chain would quickly burn. Phytoplankton and topsoil microbes would die off, initiating a total ecosystem collapse that makes global mass extinction unavoidable in a matter of weeks. The observable universe spans over 90 billion light-years. It contains hundreds of billions of galaxies. Each one holds billions of massive stars, all burning through their lifespans, all carrying the potential for a catastrophic collapse. The mechanics of space are indifferent to biology. The universe was not constructed as a safe cradle to protect living organisms. It is inherently violent and entirely arbitrary. We are sitting on a small rock, existing through sheer statistical luck. Life continues only in the temporary, silent gaps between unimaginable extremes.